Okay, so now we are going to look at 2018 Paper 2, Question 8 on trigonometry. So at the start of the question, it's got a picture drawn, which has triangles in it, which is how you should know it's trigonometry. It says the diagram shows a section of garden divided into 3 parts. In the diagram, POR is 3.3, so the length from P to OR is 3.3. PQ is 6.5. QT is the same as QS, and they're both 8. QPOR is 90 degrees. PQOR is called alpha, and the angle ORQS is called beta, and alpha and beta are on a straight line. Okay, part A, it says use the theorem of Pythagoras to find ORQ. So theorem of Pythagoras means you're looking at a right angle triangle. So the triangle we're looking at is this one. In terms of using Pythagoras' theorem, you have to identify your sides correctly. So go to your 90, put your line going across. So your 6.5 is your hypotenuse, okay? So in terms of Pythagoras' theorem, that is the side which is on its own. So you've got 6.5 squared is equal to the sum of the other two lengths squared. So we've got 3.3 squared, and you've got ORQ, which is what we're looking for. Okay, you maneuver it around, so you've got 6.5 squared. Take away your 3.3 to be squared is equal to your ORQ squared. Now, when you moved the 3.3 across the equal sign, the minus sign is outside your squared sign. So when you were squaring the 3.3, you were not squaring minus 3.3. So this should still get subtracted away. So we have our 6.5 squared, take away our 3.3 squared, and when you do that on calculator, you get 31.36. So your 31.36 is equal to your ORQ squared. So the square root of 31.36 is 5.6. So that's what we're saying your ORQ is. So this is 5.6, and you write it on your picture. Part B, it says show that alpha is equal to 31 degrees, correct to the nearest degree. So in terms of that, you are dealing with a triangle. The triangle is a right angle triangle. Excuse what my picture looks like. Alpha is there. On our picture, we have been told that the original 6.5 is a hypotenuse, and we've got 3.3 there and 5.6 there, which we've just solved. You want to find alpha. So it's a right angle triangle. We're not using Pythagoras' theorem. We will use one of the ratios. So in terms of the ratios, if we are dealing with this corner alpha, this is the hypotenuse, and this is the opposite. So the rule which uses opposites and hypotheses is your sine. So sine of alpha is equal to the opposite over hypotenuse. So in other words, your sine of alpha is equal to 3.3 divided by 6.5. Okay, we're not looking for sine of alpha, you are looking for alpha. So your alpha is equal to your sine inverse of your 3.3 divided by your 6.5, right? So in terms of that, your 3.3 is divided by your 6.5. It's not the whole thing is divided by 6.5. So you plug it into your calculator using the fraction button for your 3.3 over 6.5, and you get the answer of 30.51 degrees. But the question says correct to the nearest degree, so that is equal to 31 degrees, which is what they were saying, so we know we are correct. Part C, it says use the value of alpha in part B to find the value of beta. So when you look back at the picture, alpha and beta are these two angles. They are on a straight line, right? What you're meant to know is a straight line is equal to 180 degrees. So alpha and beta will equal to 180 degrees. You were told in part B that alpha was 31 degrees. So you've got 31 plus some number is equal to 180. So that means our beta is equal to 180. Take away the 31, which gives you 1 149 degrees. Okay, so that is 149 degrees there. When you turn over the page, it asks you to use the cosine rule to find the length of OR to S. So, in terms of what you have a triangle. Something like that. This is your OR. That's your S. You have just worked out that this angle is 149 degrees. You were told in the question the length of that line is 8, and you worked out that this line is 5.6. So for the cosine rule, you have to have two sides and the angle in between. So we have two sides and the angle in between. So we have to make sure we label the bits correctly. So if this is the angle, the side across from the angle is what you are going to take as A, right? Which is what we are actually looking for here, so it works. So in terms of the cosine rule, you have A squared is equal to 5.6 squared plus 8 squared minus 2, 5.6, 8 cos of 149. And you fill them all in. Then you can try and multiply the bits out. So your 5.6 squared is equal to 31.36. 8 squared is 64. 2 by 5.6 by 8 is equal to 89.6 cos 149. So I have all that filled in. Then if I tidy it up on the calculator, and plug them all in, this side, to the calculator, I get A squared is equal to 172.1621. Okay, so just remember this 89.6 is multiplying your cos 149, so don't subtract it from your 31.36 and 64. Okay, so A squared is 172.16, so that means A is the square root of 172.1621. So A is equal to 13.12. So correct to the nearest meter, so we are saying is equal to 13 meters. So your OR S is equal to 13 meters. Then you go to part E, and part E is to do with arcs. It says SQT is a sector of a circle whose center is Q. Find the length of the arc. So if you look back at our picture, they're saying this is a section of a circle. They want to find the length of the arc, which is this. So in terms of the length of the arc, you have the radius, which is 8. You need to know this angle. So this angle is the same as this angle because they're either alternate angles or you count that it's on a straight line. So this angle is 31 degrees. So the formula to calculate an arc is, just look it up, it's in the log tables and it is down as theta over 360 times 2 pi or. We are dealing with degrees here, so make sure you're using the degree formula from the log tables, not the radian one. So this is a formula, you then plug it in. So you're going 31 over 360 times 2 times your pi button on the calculator. Do not put in 3.14. And your OR was 8. So when you plug that into the calculator, you get 4.3284. It wants the answer correct to one decimal place. So you're going just 4.3 because the second decimal place was less than 5. The final part of that question wants to find the area of the sector. So the formula for the area of the sector, again, is in the log tables. It's theta over 360 times pi or squared. So you're going 31 over 360 times pi times 8 squared. Again, you're using the pi button on the calculator. You just plug it in and you get 17.313. They want correct to one decimal place, so 17.3 meters squared. Okay, and that's that.